Cumulus networks. I'll start with about 5 slides, a bit of an introduction. I've seen some familiar faces. We have our own meetup group here as well. Not working now?
Now it is.
Yeah, okay. So who has never heard of Cumulus networks before? Okay, so that's good. So we're a network operating system. You install that on a box. There are some boxes. And let's go to the operating system. So we are based on a Linux operating system, standardized Linux, and we use all the standard tools for doing your network management. And most importantly, for the automation part here, you can use all the standard tools that you probably all are already using. Now, Silla asked me to present a while back, actually, before the summer, I think. And I made a presentation about continuous integration and how to do that. So then she asked again last month. And I said, well, I'm worked on the new demo, and there's some CI in there, but a lot of functionality, tools, automation, open source tools, and I'd like to show that. So the rest of the presentation, I'd like to spend some time on that. Now, basically everything that we develop is being open sourced. So if you ever buy a white box switch, it comes with a bootloader that's called ONI, the Open Network Install Environment. And it allows you to install Cumulus or another operating system if you prefer that. But also the Linux networking development itself. So the VRF implementation in the Linux kernel is developed by Cumulus. MPLS, we have several maintainers from the free-range routing team working for Cumulus, but also smaller tools. And that's important because I'm also using these tools on a regular OS, just Ubuntu on a server in the demo itself. Now, how am I demoing all of this? Cumulus, like other vendors, has a virtualization environment. You can download that for free. But one important thing is that we use the Linux kernel for all the basic forwarding content. So that means that regardless of hardware or virtualized, you have the same interaction with the forwarding path. I don't really like comparing myself or Cumulus with other vendors, but I know that there are other vendors that use, for example, a script for forwarding a packet in the virtualization environment. But for that, we just use the standard Linux kernel. So you have the same interaction. No one needed to redevelop the ARC protocol, for example. Now, with that, I'd like to start with the demo. Okay, you hear me a bit in the back there. I hope this works. So I made this new demo. I put it on GitHub about 2 months ago. You can download it for free and run it on a server if you like to. And basically what I started out with, I was working at a customer with VOC. They are planning to build a CI environment, and one thing that they want to do is want to have a complete copy of their network. So the same topology that they are using in production, they want to use that virtual. So I started building that for them, and I was like, okay, I can put all of this in the demo, and at the same time working for other customers, so I pulled in all the functionalities that everyone is using. Now, as I said, we have Cumulus VX, our virtual environment that you can download for free, but you can also put that in a topology. Now, one standard topology that we have, we call that a reference topology. 2 spines, 4 leaves, 4 servers. And servers are just Ubuntu. And you use Vagrant to boot them up, and you can manage them like you would normally. Now, obviously, this is not a copy of a production environment. Usually, production environments are a lot larger and you want to dynamically provision boxes and so on. So one of my colleagues, he's maintaining our topology generator or topology converter. There is some code for me in there, so don't do it too hard. But what you can do is you input a PTM file, that's for prescriptive topology manager, and that's an open form of how you can define a network topology, and that will generate a topology how you have defined it. Now that's what I started out with. So what I did is I defined a two-pod topology, super spines, edge leaves, routers. I have a management server there, also running software from us that we call NetQ to do network validation. And on top of that, I built an EVPN configuration with multi-tenancy, both layer 2 and layer 3. All the servers are Ubuntu. I'm running VRF on that host. So I'm showing that as well, so that you have separate routing tables. And that are things that I'll go over during the demo. Now, let's start with the first part. Now, I have looked at most of the topology already, but what you can see is I destroyed two of the nodes earlier, so I could reprovision them with a configuration that I already have. Obviously, I'm doing that all with Ansible. It's not that we don't support any other tools. You can use any of the tools that you regularly use on Linux already. But we have chosen internally that we use Ansible for demos and such, and we see that it's quite popular. Now, if I have a quick look at how I did the configuration of the EVPN environment. So what I did is I made 3 tenants. They are layer 3 VNIs, and I all tagged them with a VLAN to the servers where I have VRFs configured. Now, it's quite a lot to go over in about half an hour, so feel free to take your time afterwards to read through it. I think that there are a lot of diagrams on there as well. But let me log in. So I'm logged in right now on an out-of-band management server. That is part of the topology, and from there I can SSH into all the switches that I have. So I can here leave 01, or if I wish, at 01. Now, that means that you can see that I don't have to define any credentials, so I'm using SSH keys to log in. And that is something that I'd like to show for the 2 nodes that I've just booted with favorite. So you see that I booted leaf 03 and leaf 04. And one thing that you can see here is that the configuration is completely random. No. Is that better?
You can bring it up higher.
I don't have more screen. So this is the best I can do for you.
Can you make the window smaller?
Window smaller. Yeah. So as you can see, the network interfaces file, that's completely empty. Well, there are some standard vagrant interfaces and such, because I destroyed them and I'm going to reprovision them. Now, how am I going to provision them? So in the demo itself, I have various Ansible templates. I've divided them over the roles. I can visit them all and give you a complete explanation, but I think that will still be here in the next 2 hours or so. So what I'm going to show you here is that I have a very long YAML file that contains contains all the configuration for a specific node. So in this case, you see all the variables for MVAC that I'm using, what the members are, peer IPs for the overlay network, and this is all defined or being pushed using a Jinja template. So if I'm going to have a quick look there. So what you see is that it's a standard etc network interfaces file that you normally have in Linux as well. As you can see, it's all Jinja code. So that means that you would handle a configuration file like you would do on a normal Linux server as well. That also means if you want to move to Salt Stack, you can use the same Jinja code as well. You have to change your playbooks or whatever they're named in Salt Stack, but you can use the same code. You're not depending on any modules that we develop. Cumulus does have a module for Ansible, so we can do that. Now, let me have a look back at this YAML file. So, as you can see, there are quite some variables. When Sila just asked who did something with automation, no one said that he didn't. So, who has variable files like this? Okay. And the ones who have, do you manage them by hand? Or who manages them by hand? I see a few out of, what is it, 70 people or so? Now, that's one of the things that you don't want to do in your company. And at least you don't want to be the guy that will gets called out of bed at 2 a.m. and wants to go through a variable files by hand. So what I did is I used a tool called Netbox. Netbox is an open source tool, and that's created by DigitalOcean, and it's used for IP address management, device management, and it has a lot of nice APIs. Now, they do have made choices for their data model. How are they going to store all the variables? How are they managing that? So the advantage is that you don't have to or need to have that discussion internally, but on the other hand, you do have to work with whatever they have developed. So one thing that I did is I have the leaf 03 and 04. I've set them to offline right now. And that means that right now there's no configuration being imported if I run the import script. But what you can see is I already filled in all the configuration. So I have IP addresses, I have VRFs defined, I have bonds defined to the servers, etc. Now, what I'll do is I have a Netbox Python script, and it queries the API, and it outputs JSON that can be read by Ansible again. So if someone makes a change through the GUI, and I do a re-import, then it will put out in JSON in the same format so that it can all read out the same configuration. So if I'm looking here in this configuration, you see that leaf 02 is the last one. And simply because I don't want to click 100 times, is that I'm going to just make these two active again. And if I run my Netbox script again, you'll see that the output will include those two nodes as well. Should take a few seconds. But as you can see now, right now I have the 04 here in the configuration. So what I'm going to do is I'm going to run my Ansible playbook. And I'm going to reprovision leaf 03 and leaf 04. So it uses the variables that I have and the templates to put in all the configurations, both for routing, for free-range routing. So it sets up all the BGP sessions, EVPN, etc. And it will provision everything as it should be. So that will take a bit. Let me see what can I show you in the meantime. Now, let me log into one of the servers that I have here. So server 01 that I have on the left side, all the way down here. So if you can't see it, just stand up. But let me move the window then. So what you can see is here on the left, and you can see that this is a standard Linux kernel, or well, I upgraded it a bit because I needed VRF support. But 4.13 is now about a year old. So one of the things that I did is I installed the VRF tools and created a few VRFs. Because I have multiple tenants, multiple VLANs going to a server, I don't want to create static routes to do demos and such. I just want to have one default route per VRF. So that doesn't have any route. So what you can see here, if I'm typing it correctly, you see that there's just one default route inside the VRF. So I can also just ping external hosts from the VRF as well. So one thing that I've set up is I have an external router in this topology. So if I go back to the topology, you see two of the external routers. I've configured a few SVIs, and they are terminating the layer 3 VNI. So right now I can just traverse traffic. It's being encapsulated over the network, and I do have reachability. So that does mean that I can basically do everything. I can test data plane traffic, and of course, I can also do it for IPv6. So that's IPv6 encapsulation in a layer 3 VNI for with EVPN. Now, picking a host, that's nice, but yeah, I think we've all seen that in a demo, so that's quite boring. So one thing that I did is I built another Ansible playbook. What this Ansible playbook does is it sets up hyper on all the servers, on all the virtual servers, and it sets up about 100 streams of a few kilobits between all the servers in a full mesh. So as you can see, it opens up quite some ports, and it's actually sends traffic between the virtual hosts. So if you want to test a virtual application, you can actually do something like that. Now, how do you want to, or how do you see if it's actually sending traffic? And as you can see, it sends both IPv4 and IPv6 traffic. You obviously want to see some statistics. Now, what you see here is you see some control plane traffic, and this is Grafana, by the way. And our NetQ tool can export interface statistics as well. And what you should see in a few seconds is you should see a spike, and a few ambient traffic is being sent over these two leaf that I've selected, and that are things that you can measure as well. And that always takes longer when it's a demo. Yeah, there. So it's not that much, it's a virtual environment, but if you want to test, say, a container deployment, or you want to test a VM deployment, etc., then you can do so as well. Now, in the meantime, it should have provisioned leaf 03 and leaf 04. So leaf 03 was empty, as you can see before, but if I do the EC network interfaces again, then you see that it has provided or provisioned server ports with the appropriate VLANs, and that are all coming from netbox and the generated variables. Now, what you see here are some SVIs with both IPv4 and IPv6. Here are some post-ups. I had to include them because while building this demo, I ran into a bug that we have solved in the meantime. All the VNIs are defined here, and also layer 3 VNIs and VRFs for the tenants. So all the traffic is encapsulated as well in a layer 3 VNI. Now, one other thing that we have, and that's quite interesting to show you. We have the NetQ tool, and the NetQ tool that is an agent that is running on all the switches itself. Like our switch daemon, it takes data from the netlink messages from several applications, but it sends it to a centralized Redis database. And that means that from one point in your network, using the tool, you can do validation of your network. Now, in this case, you see that even the servers have the agent installed. So that means if you have a standard Linux server, you can install an agent and do network troubleshooting with that as well. And one thing that we did, for example, is that we built in simple checks. And that is what I'm using for my continuous integration. So what I'm doing in continuous integration is that I spin up a copy of a production network, provision it with Ansible, with variables that I can maintain in the netbox. And when that virtual topology is all booted up, I just do some simple check commands to see if everything is still working as it should be. Now, if it doesn't work as it should be, then what you'll see here is you see a simple exit error. And if you use GitLab, for example, then you'll see that the check will fail. I've still an old pipeline open in the CI/CD, but let me see. This is actually my colleague over there did last month. Now, what you see is that if there is an exit code and something went wrong, then the GitLab runner, it quits and it doesn't get, it's not ready for moving to production. So that's quite easy to build your CI system using a few simple checks, and you can add your own, of course. Now, one thing to end with. We'll hear effort troubleshooted an MTU issue in their network. Okay. Now, I'm going to solve all my MTU issues in one check. Basically what we do is, because we have all the links, we know which links belong to each other based on LLDB information, and you see if the MTU size configured are the same. And in these few seconds, you see that there are, that these check 520 links. Well, I think that if you have an MTU issue, which you usually don't even know, you have to troubleshoot a lot before you even know it's an MTU issue. These kinds of checks do help very much. Now, I think that's pretty much the end of the demo. If you're interested in more EVPN and how you could integrate that with host operating systems, I hope that my talk at RIDE next month will be accepted because I'm working on a new demo where the idea is that I integrate VRFs on the host, but also with EVPN. So if you're at RIDE in Amsterdam, feel free to come by. With that, I'd like to thank you.